out! There's an object hurtling toward Earth at the speed of light. And no, it's not a comet or an asteroid. Yeah, it's a marshmallow. How could a marshmallow ever go this fast? What would happen to it as it entered the atmosphere? And what kind of damage would it do to our planet? This is What If, and here's what would happen if a marshmallow hit the Earth at the speed of light. Early versions of the marshmallow were first eaten as far back as ancient Egypt. But in the 1950s, these sweets made from sugar, water, and gelatin exploded in popularity. In the United States alone, about 40 million kilograms are sold every year. And over half of all marshmallows sold during the summer months are roasted over a campfire. And then squished between chocolate and graham crackers, some more. Well, I'd like some more of that myself, so let's see what happens when we make the most epic s'more possible. Time to send this fluffy treat hurtling toward Earth at an impossible speed. Warning to all the althiophobes out there, things could get gooey. But forget the marshmallow for a second. If you're writing without Grammarly, you're already in a sticky situation. Grammarly's AI-powered writing assistant keeps my emails, texts, and scripts mistake-free, so my message comes across clear. And with seamless integration across all devices, I can write confidently to any audience at any time. Grammarly Premium even suggests whole sentence rewrites, eliminating unnecessary words and finding better word choices. I can write in my voice with customizable settings instead of sounding like some robot. Write with confidence with Grammarly Premium. And right now, get 20% off Grammarly Premium at grammarly.com/whatif. That's 20% off at grammarly.com/whatif. Now, get a graham cracker and some chocolate bars. The only thing hotter than this deal is the marshmallow flying right at you. In a vacuum like outer space, the speed of light is 299,792 kilometers per second. That's so fast that an object traveling at that speed could circle the Earth 7.5 times in 1 second. As far as we know, no object can travel faster than light. That's because the faster an object moves, the more its mass increases. If an object moved at the speed of light, its mass would become infinite. And to move an object with infinite mass would require an infinite amount of energy. And therefore, it's impossible. Until now. If you were an astronaut on the International Space Station, who could blame you for feeling the primal call of a good s'more? It would be a perfect way to pass an idle summertime evening 420 kilometers above the surface of the Earth. But don't worry, you wouldn't need to light a campfire on board the ISS. These space station oven-toasted marshmallows would be completely harmless. Except, wait, one is missing. Uh-oh. If a marshmallow escaped the pressurized environment of the ISS, it would start to expand. That's because marshmallows have small bubbles of air trapped inside them. On Earth, the outward pressure of these air bubbles and the inward pressure of the surrounding air reach a stability that results in a normal-looking marshmallow. But in the vacuum of space, with no surrounding air pressure, the air bubbles inside the marshmallow would expand. That would make it puff up even larger. Now, our misshapen marshmallow would set its sights on Earth. And here's where the impossible would happen. The marshmallow would begin to travel at 99.9% the speed of light, reaching the Earth's surface in less than a millisecond. Okay, how about we roll things back and follow the action in slow motion? As the marshmallow enters our atmosphere, it would begin to slam into the atmospheric particles. At this ridiculous speed, these particles would actually punch into the marshmallow and stay there. So, the marshmallow would actually gain weight as it hurtled toward Earth. This highly energetic scenario would most likely cause the marshmallow to rip apart. This would be a saving grace for us down below because it would create explosions that would dissipate the energy during its trajectory. But if that didn't happen, this once fluffy object would hit the ground with a lot of force. Take the Chelyabinsk meteorite as an example. This meteorite exploded at a height of somewhere between 19 and 24 kilometers over Russia in 2013. With a mass of 11,000 tons, the overhead explosion injured 1,000 people. Our beloved marshmallow, moving at the impossibly fast rate of 99.9% the speed of light, would slam into Earth with a force almost 4 times more powerful than what occurred during the Chelyabinsk event. And it wouldn't hit the ground as a soft, sticky substance either. If it managed to avoid completely burning up in the atmosphere, the high-temperature journey would cause the carbon in the marshmallow to darken and harden, converting it to graphite. The damage that this tasty treat-turned meteorite could inflict upon Earth would depend on where it landed. If it remained intact and smacked right down into New York City, a 2019 NASA simulation estimated it could result in the death of over 1.3 million people. Okay, maybe NASA didn't actually simulate the impact of a marshmallow meteorite traveling at the speed of light. Their simulation was a much larger 60-meter sugar-free asteroid entering Earth's atmosphere at a comparatively slow 19 kilometers per second. Our marshmallow would likely be less powerful than this asteroid, but it would grow in danger as air atoms would be punched into it during its trajectory. And with more mass comes a greater impact force. You know, it makes you wonder, what else could we launch at the speed of light toward Earth? Maybe a turkey? But that's a story for another What If.